Hello students, this part on ray optics and optical instruments part 6 is brought to you by VGuide TV. In this part I am going to explain power of a lens, lenses in combination and lens formula. First we will discuss about the power of lens. This I drawn a convex lens. The ray is coming from infinity. So when the light rays are coming from infinity, we know that it goes to a point called focus. Right? So here, if you extend your incident ray backwards, this is the dotted line we are getting. So from this dotted line, how much it is getting diverged, or how much, what is the divergence or convergence? So it is in this case means it is getting converged to a point called F. So we can define the power of a lens is defined as the tangent of the angle which it converges or diverges a beam of light falling at a unit distance from the optical center. It means, see here, we are taking this angle, I marked a symbol called delta. Okay. So, if this is delta, by alternate interior angle, this also will be delta. So, if you find tan delta, I can write it as opposite side by adjacent side. Adjacent side means the distance from optic center to F. Optic center to F is called focus. So we can write tan delta is equal to h by f. H is height and f is this one. Here you take this h as 1 meter. It means unity. So if h is 1, I can write tan delta as 1 by f. If delta is very small, tan delta you can approx to delta. That is delta equals 1 by f. And this 1 by f we call by a name power. So how we are getting the power? We are taken a convex lens. The light ray coming from infinity light rays are coming from infinity. It is converging to a point called focus. So this angle you marked as delta. You extend the incident ray like this. So this angle also delta. This will be delta. This is delta. Consider this right triangle. According to this right triangle, tan delta is opposite side by adjacent side. So it is h by f. And we take a condition that h equal to 1. If h equal to 1, we can write tan delta equals 1 by f or delta equal 1 by f. This is called by a name power. So now look at the definition again. Power of a lens is defined as tangent. Yes, tan of the angle. Tangent of the angle at which, what is this angle? How much it converges or diverges a beam of light falling at a unit distance. This is the unit distance. I am taking h as 1 from the optic center. So we are taking the distance from optic center. So this is called the power. It is also defined from this equation as reciprocal of focal length. And its unit is diopter. And you remember the power of a convex lens is positive because focal length of convex lens is positive. Power of a concave lens is negative because focal length of a concave lens is negative. Okay. Now, next is, you see here, there are two lenses we are combining. Okay, this is first lens, second lens. In the last video, I told about lens maker's formula. So if you are using two lenses, you have to follow the same theory or same principle. It means we are keeping an object here. With the help of this object, I am getting an image. That image is called I1. This image acts as an object for the second lens and we get the final image. So you have to remember here, when the lenses are combined like this, we have two lenses and O is the object. With the help of this object, First I am getting an image, that is I1. I1 is the first image, you remember. And this image acts as a virtual object for your second lens, and we are getting the final image at I. This is the ray diagram. We have to mark it. Symbol diagram we are doing. Okay. Now after that you have to use the lens formula for two lenses. For the first lens, you know that your object distance is u. Image distance, I put it as v1. So you can write the lens formula 1 by v1 minus 1 by u equal 1 by f1. Because we are taking the focal length of the first lens as f1, focal length of second lens as f2. Now, next I told this act as an object for the second lens. This act as an object for the second lens, and we get the final image I told. So here this is nothing but an object distance for the second lens. So you see 1 by v minus 1 by u. U is nothing but this distance. Which distance? First image distance act as the object distance for the second lens. So 1 by v minus 1 by v1 equal 1 by f2. Take it as equation number 1 and 2. Add these two equations. 1 by v1 minus 1 by v1 get cancelled. So we can write 1 by v minus 1 by u equals 1 by f1 plus 1 by f2. Here 1 by f1, if you see the left side, it is your lens formula. So right side should get the focal length. So we can call it as 1 by f1 plus 1 by f2 as the effective focal length f. Or you can write it as 1 by f equals 1 by f1 plus 1 by f2 is the effective focal length. Now, take the case in which there are more lenses. If more than 2 means 1 by f1, 1 by f equals 1 by f1 plus 1 by f2 plus 1 by f3 plus etc. Next, 1 by f is called power. Just now we have seen. So power equals P1 plus P2 plus etc. And another main thing, as the lens is increasing or the number of lens increases, the magnification is increasing. So M is M1 into M2 into M3 like etc. Then there is a case. It is not compulsory. These two lenses are always like this. Even if they have a separation like this, this is one lens. We are keeping another lens here. Okay. They are separated by a distance d, means your focal length 1 by f is 1 by f1 plus 1 by f2 minus d by f1 f2. This is the equation for focal length when the lenses are separated by a distance of d. So this is a combination equation. This is important. It means they don't have any separation. If they have separation, you use the equation 1 by f equals 1 by f1 plus 1 by f2 minus d by f1 f2. Understood? What we are using? Simple thing. We are applying the lens formula for both the lenses. Image of the first lens acts as an object for the second lens. That's the main thing you have to remember. Then adding the equations. In the previous video, with lens maker's formula, I derived lens formula. But this is the simple with congruency or with similar triangles we are proving the lens formula. This is your lens object. Light ray coming parallel to principal axis. After refraction, it goes through focus. The light ray which passes through optic center goes like this. They got intersected here. We get an image here. Object, image, right? Same like mirror formula how we derived, we have to consider two triangles. So first I am considering the triangle ABO, that is object with optic center and image with optic center, that is A dash B dash O. Take the similar sides. AB by A dash B dash is equal to BO by B dash O. Equation number 1. So first I am taking which triangle? ABO, that is object with optic center and image with the optic center, big one. Next you take the triangle with respect to F. Okay. So f, object with respect to f, image with respect to f. But with object and f, the triangle I did not mark. So you can take here this part, like a PO and your AB are parallel sides. They are same. So I am taking the triangle POF, that is this triangle POF and FB dash A dash. We are taking two triangle. One is POF and another one is FB dash A dash. Here also you take the similar sides. That is A dash B dash by FB dash is equal to PO by OF. PO by OF. Okay, just take the sides. This with respect to this. This by this, that should be equal to this with respect to this. And here I told PO is nothing but AB. So instead of PO, I wrote AB. So AB by OF equals A dash B dash by FB dash. Again we are cross multiplying and writing AB by A dash B dash equals OF by FB dash. Equation number 2. In short, you remember after drawing your ray diagram, you have to take first two triangles with respect to optic center. Object with optic center, image with optic center. Next you take two more similar triangles. Which one? The triangle which is like which are coming opposite of F. Object with F and image with F. Take the similar side. So when you are taking the similarity, you remember always we need the object to image ratio. So AB by A dash B dash. So we are getting both the two and we are equating these two. When we are equating, equation number 1, that is BO by OB dash equals OF by FB dash. BO by OB dash equals OF. OF by FB dash is, what is FB dash? FB dash, we can take it as OB dash minus OF. Then after that, you are taking the distance as BO. BO is nothing but, what is BO? Object distance minus U by OB dash. OB dash is nothing but image distance V. Okay, we apply the sign convention and putting OB, it's coming this side. So distance we are taking opposite to the direction of incident light. So minus U by V equals OF, focal length F, OB dash V minus F. Cross multiply. Minus UV plus UF equals VF. After that, next step is dividing by UVF. We are dividing the total equation by UVF. So UV is there, F will come. UF is there, V will come here. VF is there, here we get U. So we get an equation 1 by V minus 1 by U equals 1 by F. This formula is called Lenz's formula. And we already know that what is magnification equation? HI by HO, that is also equal to V by U. Okay. So in this section I discussed about power of the lens, lens in combination, lens formula. I am giving two simple questions. Two lenses of power 10 diopter and minus 5 diopter are placed in contact. So no problem, contact only. Calculate the power of the new lens. Simple formula. Then where should be an object be placed, be held from the lens so as to obtain a virtual image of magnification 2. First part is simple, power of combination P1 plus P2. That is 10 minus 5 is 5 diopter. Next, what is focal length? 1 by P. 1 by, remember here, diopter. 1 diopter is nothing but 1 meter inverse. So it means that 1 by 100 centimeter. That is the meaning. So that is the reason 5 diopter means 5 by 100 centimeter. So this goes up. So I'll get 100 by 520. This is the main thing you remember. Then question they are asking, where should an object be placed? So we need U. But they gave magnification. I showed like this one shortcut method for mirror also. So here I am doing only for one. Magnification is V by U. 1 by v minus 1 by u is 1 by f. Multiply the whole with u. So u by v minus 1 equals u by f. What is u by v? It is 1 by m minus 1 equals u by f. 1 by m equals u by f plus 1. Take LCM. It is f by f plus u. So in this only I substituted. As it is a virtual image they gave, magnification is positive. Okay. So 2 equals f they gave 20 and moreover, see I got a positive answer only. So it is a positive. It behaves as a convex. So it is 20 by 20 plus u. 40 plus 2u equals 20. We will get it as minus 10 centimeters. So you see, it's no need to keep a sign convention for u before. If your substitutions are correct, you will get automatically u in negative only. So I need to focus two things from here. One is to convert, how we are converting the diopter to centimeter and all. Another one is magnification in terms of f and u. Then virtual image means magnification is positive and real image means magnification is negative. Okay, sign convention also. Next, this is a very interesting question. You are given three lenses L1, L2, L3 each other of focal length, each of focal length 10 centimeter. An object is placed 15 centimeter in front of L1. Okay, an object is placed 15 centimeter in front of L1. The final image is formed at the focus I of L3. What are the separations of L1, L2 and L3? Very important question. They are given three lenses like this and all focal length are same. All the focal length are 10 centimeter. Okay, an object they placed here in front of first lens, a distance of 15 centimeter, they are keeping an object. They told you are getting an image here at focus they told. So from this a lot of things you have to correlate. Okay, so in the first video I told you have to do all the ray diagram. For this type of question you should have an idea. Okay, so first I know the object distance, I know the focal length, so I can find where is the image located for the first lens. That only I did first. For the lens L1, 1 by V1 minus 1 by U1 equal 1 by F1. 1 by V1 is 1 by, I substituted the value, plus 1 by minus 5, applied the sign convention. That is equal to 30 or V1 equal 30 centimeter. Our question is, I don't know where this lens and this lens placed. But I know that the image of the first lens I am getting at a distance of 30 centimeter. Keep at its side. Now coming from the back side of this image at focus they told. If the image is at focus, we know that object should be at infinity. So it means that here I am getting for the L3 object should be at infinity. If L3 object should be at infinity means, who is the object of L3? Object of L3 is nothing but the image of L2. So it means that image of L2 is at which point? Image of L2 is at infinity. Image of L2 is at infinity means object of L2 is at focus. Okay, I'll tell again. They told L3, they gave here the final real image is formed at focus I of L3. So it means I am getting here the image. If we need focus the image means where should be your object? Object should be at infinity. If the object is at infinity, this object of L3 is at infinity means image of L2 is at infinity. Image of L2 is at infinity means where should be the object of L2? Object of L2 at focus. So I can take that here should be the object. Then who is the object of L2? That is nothing but image of L1. We know that image of L1 is at a distance of 30. Okay, so I am getting a distance of 30. But from that point to the lens, I should have a distance of 10. Then only I'll get the image of L2 at infinity. So what I am doing is separation of L1 and L2 is V1 plus U2. U2 is your focal length. V1 we got it here 30. So 30 plus 10. We have to take mode value only 40 centimeter. But for getting these two distance, it can be of any distance because it is infinity they told. So it can be little far. Okay, it may not be like any specific distance and all not required, right? So we can tell that the separation of L2 and L3 can have any distance because the object of L3 is at infinity. I hope you got it. First I started from here. I found the image. Then I started from here. This is at focus means object of L3 is at infinity. Object of L3 infinity means image of L2 is at infinity. Image of L2 infinity means object of L2 is at focus. Okay. Thank you. Subscribe for more videos of class 1 to class 12 for both foundation, JEE, NEET and NTSC, V Guide Physics, V Guide TV. Thank you.